In this video, we will learn how to calculate the maximum sum of non-adjacent values in an array without using recursion. Hello, and welcome to the Python implementation of LeetCode problem 198, House Robber. The problem states, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money in each house, return the maximum amount of money you can rob tonight without alerting the police. For example, example 1. Input nums is 1, 2, 3, 1. Output is 4. Rob house 1, money is 1. Then rob house 3, money is 3. Total amount you can rob is 1 plus 3 equals 4. Example 2. Input nums is 2, 7, 9, 3, 1. Output is 12. Rob house 1, money is 2. Rob house 3, money is 9. And rob house 5, money is 1. Total amount you can rob is 2 plus 9 plus 1 equals 12. The constraints are, the number of nums is between 1 and 100, and each number can be between 0 and 400. What this is really asking is, we have an array of nums where each item in the array represents the amount of money that can be robbed from a house on a given street. You can rob any houses as long as they aren't next to each other. You want to sum non-consecutive values in the array such that the sum of these elements is as much as possible. This is a dynamic programming problem. We can guess this because it does not work on a linked list, graph, or range. It does not find a target value, minimum or maximum. It has small bounds, and it has an inefficient iterative solution. If you're serious about acing coding interviews, then I've got something that will help. Sign up for the LeetKey newsletter and get weekly LeetCode problems, detailed solutions, and proven strategies delivered straight to your inbox. Now back to the video. You might be inclined to solve this by recursively checking for the max sum of values for every distance between two or more elements in the array. But this approach requires exponential time complexity because it requires nested loops. A more optimal approach is to use dynamic programming to store two running maximum values. Then you can move along the array once at each stage, finding the maximum value of non-adjacent houses and adding it to the running total. So that we always know the maximum of the two paths, we also store the value of the maximum path up to this point. Then we can update the best path for each next step. You can continue this across the array until you reach the end, keeping a running total of the maximum possible value from the sum up to the last two houses. This way, we always know which is the next most valuable house to rob without robbing two consecutive houses. The final outcome is the maximum of the last two paths. This solution iterates over the nums array only one time and doesn't create any unnecessary data. Let's see how to implement this solution. This solution keeps a running track of the money earned from looting possible houses. Start by setting the gains from all paths to 0. We loop over each house, comparing how much money is earned if we rob that house. At each step, we add the money stolen up to two houses ago. Then take the maximum of that path or the money up to the last house. We keep track of our progress by updating the value from 2 houses ago to include the last one, and the value up till now to be the maximum up to this point. This continues until we reach the last house, finding the maximum value of robbing this house or skipping it in favor of the next. When the loop finishes, we return the maximum possible money stolen. The space complexity for this implementation is static, since we reuse the prev and cur values for any size loop. The time complexity for this implementation is linear, since we must look at each house in the array to compare each potential value. That was how to solve LeetCode problem 198, House Robber. Thank you, Ritesh, for subscribing. Next week, we will be looking at problem 790, domino and tromino tiling. So, subscribe and click that bell to get notified when that drops. And let us know in the comments which problems you'd like to see next. Please share this video with any programmers or aspiring coders that you think would benefit from its insights. It's word-of-mouth referrals like yours that really help this channel grow. You can get this video a few days earlier, plus other exclusive content on our Patreon.